Can we start, Pa? Or you want still some more people to come? Last hour, so I know it is difficult for me to hold you. So there is a circular from Anna University. I don't know how many of you gone through it. Right now, from college we didn't get anything, but Anna University is telling us. So you can see here. They are telling us to start from 8. So this is the schedule which Anna University put. First year by 8, second year by 15th, third year by 05/04/2021. So I don't know. Based on this, our college will decide when you should come. So as per third year, I don't think you will be coming 05/04. Okay, let us not bother much about that. We will bother about this. Shall we start, Pa? So morning we are discussing about the isotherms, the physics option, chemist option, the difference between the. One important thing in any isotherm is the monolayer coverage. Then different isotherms, different authors gave different isotherms. Again, everything is based on QE versus CE. How much it is getting absorbed and what is the equilibrium concentration. So some people gave linear expressions, some people gave non-linear expressions. So you can see here it is an order of 2 constants. But if you see others, it will be an order of more than 3 or 4 constants also. So even now, a lot of isotherms, different isotherms are being proposed. The most popular is this. Okay. So these are the types of the isotherms. If you do an experiment and try to fit your data into, it falls into one of it. Next comes how to write the rates in adsorption. First one is rate of adsorption, then rate of desorption, and if there is a reaction is happening, then how to write the rate. Once you write the rate for all the 3, then not all the 3 will be controlling rate controlling step. Only one out of these 3 will be rate controlling. When only one out of these 3 is rate controlling, then how to write the overall rate, that is global rate. That is what you will be studying in the next some 2 to 3 what do you call classes, right? So if you see in this presentation, it is just we didn't give much about how it is being come, right? So this was straightforward taken from some books. He didn't give much derivation. So for this, I add some derivation. How you are getting this? I'll go back to my own notes. This is my own notes which I wrote in 2003 when I'm studying my MTech and all. So this also I will circulate to you. You can go see this. So this particular kinetics, especially, is it fine? You can able to see this, Ima?
Yes, sir.
Yeah. So just now morning I'm talking about global rate, observed rate, overall rate, apparent rate, everything is seen, right? So let us not go into much. Here one important thing is intrinsic rate. All homogeneous reactions, whatever your rate you are doing, it is the intrinsic rate that morning itself I talked. Here one important thing is, if you want to write a non-homogeneous reactions, you make one assumption that at a steady state, all the steps would be equal, and this equality will be used to develop the global rate. Once you do that, you can eliminate the intermediate concentrations, which is unknown, right? That is, to eliminate that intermediate concentration, you are making that assumptions and equating it. So here, since adsorption, surface reaction and desorption gives intrinsic rate, so each step will give you an intrinsic rate. So if you want to get a globalized rate, then first the kinetic models are known as this: Langmuir, Hirshelwood, Haugen, Watson model. This model, whatever we are going to deal, is called as Langmuir, Hirshelwood, Haugen, and Watson. So LHHW kinetics they call, right? So this concept is based on an active site. You are assuming that the solid will have some active sites, so the gas will go and sit on the active site and react, right? So here actually there are two models here: Langmuir and Hirshelwood, LH kinetics, and Haugen and Watson, one more fellow. So generally they are clubbed together to give you LHHW kinetics, right? So in Langmuir and Hirshelwood formulations, what we are doing is, you can see here. Let you can see this. Yeah, let us go to the Langmuir isotherm, because in here we just gave this Langmuir isotherm. How we are going to get it? For getting this, there is some derivation. We'll see the derivation, because the derivation is required for us to go for the kinetic models. So let us see first Langmuir adsorption. Langmuir adsorption is a physical adsorption. Still, there are a lot of adsorptions, but let us use only this Langmuir adsorption. Langmuir adsorption, one assumption you make is monolayer coverage, that is uniform surface, and isothermal conditions, the temperature is constant. So let us divide the solid surface, which is having, into two parts. One is theta and the other one is 1 minus theta. So what is theta? Theta is the fraction of the surface covered by the adsorbent molecule. So the gas is there, the solid is there, the gas is surrounding the solid. Therefore, theta is a fraction which is covered by the adsorbent molecule. So if the total fraction is 1 and theta is the fraction of surface covered by adsorbent molecule, then 1 minus theta will be the bare surface which is not having any solid. Right? This just in your previous, what is that, physical chemistry you might have studied. Now how to write the rate of adsorption? Rate of adsorption is nothing but where the gas is adsorbing, where there is a bare surface only, the gas is getting adsorbed. The gas will adsorb on the gas itself, gas also, but you are assuming it is monolayer coverage. Therefore, the gas is adsorbed only on the bare surface. That is what you will assume. So how much of the gas is getting adsorbed? It will be written as Ra is equal to some Ka constant, that is the adsorption constant we call. I'll still increase the font size so that Ra is minus Ka, that is the adsorption constant. 1 minus theta is nothing but the surface which is left, or a bare surface, into P. P is nothing but the partial pressure or concentration. You can write in terms of concentrations or pressures. If you are writing in terms of concentration, it will be C. And if you are writing in terms of partial pressures, it will be P. So this is how you write the rate of adsorption. Rate of adsorption is nothing but some constant which is called as adsorption coefficient into 1 minus theta, that is the surface on which it is adsorbed, into the partial pressure or the concentration. So the rate of desorption is nothing but the gas is adsorbed on the solid. Now the product is being desorbed from the solid surface, which is occupied by the gas. Therefore, you get RD, D for desorption, A for adsorption, right? Is equal to some KD. KD is the coefficient, desorption coefficient into theta. You are getting only theta, not 1 minus theta. 1 minus theta only for adsorption. Desorption is nothing but how much fraction is being absorbed molecule. From that only it is getting desorbed. Therefore, theta will come. So at a steady state, the rate of adsorption is equal to the rate of desorption. Dynamic, we are assuming it is dynamic equilibrium is attained. Then you can equate these two equations. Once you equate these two equations, and if you write Ka by Kd, that is Ka is the adsorption coefficient and Kd is the desorption coefficient, you can put as a capital K. Then we can write theta, because there both sides theta is there. Theta is equal to K into P. P is nothing but a partial pressure divided by 1 plus Kp. You get like this, right? So theta, it can be written as V by Vm. What is V? V is the volume of the gas adsorbed, and Vm is the volume the gas adsorbed with the monolayer coverage. This is actually the theta. So theta can be written as V by Vm is equal to Kp by 1 plus Kp. Right? This already you might have studied in your physical chemistry. Not much to required here. So if you want to write in terms of, instead of P, that is partial pressure, you want to write in terms of concentration, then the concentration unit should be number of moles per centimeter square or whatever it is. So if you write in terms of concentration, then in a concentration form, the rate of adsorption can be written as the same way, minus Ra, or Ra is the rate of adsorption, is equal to some Kca is the coefficient, adsorption coefficient, into Cg. Cg is nothing but the bulk concentration, into Cm bar minus Cm C bar. Bar is giving you just to tell it is concentrations, right? So Cm is nothing but a concentration of the monolayer, minus C is nothing but adsorbed coefficient, adsorbed concentration. So Cm minus C bar. So this is the concentration difference. This is the concentration of the gas which is there, multiplied by some coefficient will give you the rate of adsorption. Just like how you are writing here. Ka is K some coefficient into how much is the surface which is being present into the pressure with which it is going. The same way you are writing here. Kca is a coefficient. Cg is nothing but the concentration into the fraction, how much is being left. That is, Cm bar is the maximum concentration of a monolayer minus adsorbed concentration. This is the driving force. So if you write like this, you can write Rd also like this. That is Rd, that is the desorption rate, is Kcd is a coefficient into C bar. C bar is nothing but the adsorbed. The same way what you write here. You are just writing theta. The same way here. Whatever you are getting here, you write here. Right. So if you equate these two, then and get theta is equal to C bar by Cm bar. C bar is nothing but the adsorbed coefficient concentration divided by the maximum monolayer concentration. You are getting Kcg divided by 1 plus K into Cg. If you put Kc as here, because there is Kca, small kc and Kcd. If you put one over the other, Kca by Kcd as capital Kc, then you are getting this particular equation. Am I right? This is the same equation what you are going to get in this. Yeah, you can do now. Ra, the rate of net rate of adsorption of component A is nothing but RA is this coefficient into the concentration into how much is the driving force. Am I right? How much is the driving force? This is the net rate you are writing. This is the forward reaction. This is the desorption. So one minus the other will give you the net rate. The same way here, what you wrote. You are writing for individual thing. If you want a net rate, forward reaction minus the backward reaction, you can write. The same way he is writing here. Forward reaction minus backward reaction. And if you put Ka by Ka star is some capital Ka, then you can rewrite this equation as Ka into Ca Cm bar minus Cm minus this particular thing. If you divide this particular thing and put as a coefficient, then Ca bar. So Vm minus Cm bar minus here is nothing but the driving force. That is nothing but the concentration of the vacant site. We can write in terms of Cv also, right? So if there is only one gas which is being adsorbed, then what will happen is Cm bar minus C bar is nothing but Cm bar minus Ca bar. C bar is nothing but the concentration which is adsorbed. If the gas consists of 2 or 3 molecules, then you cannot put Cm bar minus C bar is Cm bar minus Ca bar or Cb bar. If the gas is only, if the gas contains only one molecule, then we can, instead of C bar, we can write Ca bar. If the gas consists of some 2-3 molecules, then you cannot write like that. Other components of the reaction may be adsorbed. So Cv bar is the concentration of the vacant site per mass of the catalyst, and Ca is the concentration of A in the gas phase at the catalyst surface. Right? Like that we can do for yeah.
So we assume that only monolayer adsorption happens for the Langmuir model, no, sir?
Yes, yes.
But then how will there be a case of when we're calculating theta? You said it will be V by Vm or Vm by V. I'm not sure. So, but
yes.
So won't that mean then where is the other gas being adsorbed, sir? Because if we're assuming that only monolayer adsorption occurs, the total volume of gas adsorbed should be the volume of gas in the monolayer. No, sir?
Again, repeat. I didn't get what you.
No, sir. So the Langmuir model says that we'll be that the gas is only absorbed in a monolayer around the solid.
Yes. You are assuming it. Actually, it may not be.
Yes,
Though
sir,
it is multi-layer, we are assuming it is, we are calculating based on the monolayer only. Yeah.
So are we discarding that assumption when we come to this theta, sir, or I'm not sure?
No. This is the maximum, right? Theta will be less than 1. This is maximum. Even though you are having more volume than the what you call monolayer, we are assuming this is the maximum.
Oh, okay, sir. I misunderstood the thing. Okay.
Yeah. Okay, fine. So even though that is a multi-layer, because multi-layer again the volume how it will become difficult. Understand?
No, sir. No, sir. I thought V would be more than Vm, which is not the case. That's why I misunderstood.
No. Vm is down. Okay. So here rate of adsorption you are writing. So instead of in terms of like that. So if you are writing Ra is Ka into Ca minus Cm bar minus C bar. Cm bar minus C bar you can write as Cm bar minus Ca bar. Cm bar minus Ca bar or Cm bar minus C bar is nothing but Cv bar, that is nothing but the vacant site. So we can write instead of Cm bar minus C bar as Cv. Right? That's what he is writing here. Ca into Cv bar minus 1 by Ca into Ca bar. So what rate we are getting is the intrinsic adsorption rate. Earlier itself I told you, series of steps, the rate you are writing, that what you get is only intrinsic rate. This rate should be clubbed together to give you the global rate. So we need to do again the desorption also like this. Anyhow, we got the adsorption and desorption in the same thing, right? Because we are minusing one desorption also. So we have to see the rate of a reaction, how much it is actually happening. So before going to that, we will, what you do is, we'll simplify this equation. You can see here, the rate of concentration of A on the catalytic surface will be in equilibrium with the concentration of A in the gas phase. So the net rate of adsorption approaches zero because it is approaching the equilibrium. Now, when it is approaching the equilibrium, there won't be net rate of adsorption because driving force will be zero. And the equilibrium coefficient of A is given by Ca equilibrium is Ka, Ca, Cv bar. Cv bar is the concentration of the vacant site, and capital Ka is the absorption equilibrium constant of A, right? So Ka is nothing but, again, capital Ka is different, small Ka is different. Capital Ka is small Ka divided by Kd, small Kd, that is equilibrium constant of adsorption divided by equilibrium constant of desorption, right? So this is one more. The reaction can be like this also. Let us see a bit later this. Now the rate of desorption in the sense C dot X, because you are having a product now. This product should be what do you call, removed to come as C plus X, right? The mechanism of the desorption of the product C may be represented by like this. So the net rate of desorption will be analogous to the equation of the adsorption. You can see here adsorption equation you are getting like this. The same way desorption you get RD. So RD will be, you are writing the same way. RD is equal to minus KD CV minus 1 by Kc Cc. So you can see everything is same except one minus will come, because this is the desorption, which is the back thing, right? So we wrote the net rate of adsorption here. Net rate of adsorption you are getting like this. Net rate of desorption you are getting like this. So here one important thing is, wherever this is adsorption, you get Ka. If it is desorption, you get Kd, right? The third one is surface reaction. What is happening at the surface? At the surface, if the reaction is A plus B is giving you C, there are two ways in which this takes place. A is sitting on the active side, reacting with B to give you C dot X. C dot X is the product which is forming at the surface. This product is being desorbed to give you C plus X. C is the product. And again, the active site, it will be recreated. You can do that, or there is one more way, A plus B dot X. That is, A is reacting with B. B is in the active site, right? So B is sitting on the active site again to give you C dot X. So both things you will have, or there is one more way. A and B are both sitting in the active site and then giving you C and C dot X. So each expression will have, each case will have different expression, right? So that is what it is being shown here. If the concentration of the adsorbed product C on the surface is Cc star, this is given in terms of moles per unit mass of the catalyst, then the net rate will be same, analogous to whatever you are doing previously. Rs is nothing but the rate of the rate on the surface reaction is, this is the forward reaction, this is the backward reaction, and if you write take it out common, this Ks star, then what will happen? Ks into CACB. If you take Ks outside, then K star by Ks is nothing but 1 by Ks. If you can write as a capital K, so Ca bar plus Cb bar minus Cc bar. So now you see here, what are the reactants? Here, how to remember is, when you are writing the expressions, you see to that the first terms, what are the reactants, it will come, minus the second term will be what is the product, divided by 1 by Ks, that is the equilibrium coefficient. This is the surface reaction. You can have one more surface reaction like this. If the mechanism is a reaction between adsorbed A and adsorbed B, then it has to be represented like this. That is A which is adsorbed plus P which is adsorbed on the active side, X is the active side, gives you C dot X plus X. X is again the active side which is being regenerated, right? That is leave once it is reaction is happening. If it is like this also, again the expression you can write, right? So here one important thing is the molecule, let A be the molecule. The molecule A will react and which are adsorbed on the site immediately adjacent to the adsorbed B molecule. Hence, the rate of forward reaction should be proportional to the concentration of the pairs of adjacent sites of A and B. So here one important thing is we will write already we discussed this theta B or how much theta of the B molecule is occupied is Cb by Cm bar. Cb is nothing but the fraction of the surface occupied by the B or the concentration of the B which is occupied on the vacant side divided by the maximum monolayer. This is the maximum, right? The rate of the forward reaction from based on this particular thing, you can write in terms of your concentration also. R is the forward reaction, Ks that is the surface, that is surface reaction, forward reaction is Ks, Ca bar, Cb bar by Cm bar, because theta will come. Theta is nothing but Cb bar by Cm bar. You are just substituting that. So like that reverse reaction also you can write. Reverse reaction is K star is the reverse, Cc bar, Cv bar by Cm bar. So if you combine these two, then you are getting this expression. You are getting this expression. You can simplify this small case instead of by putting a capital K. So whatever way you are putting, again I am telling you, this is what you get. Now you see here, what is the reaction? A, B and Cx and X. So can we write the expression now? Ka, you can see here, K divided by Cm. So what is the two coefficients? Ca, Cb, that is what it will come, minus what it will come? Product will come. So C bar, Cc bar 1 by Cv. Cv will come because there is a vacant site which is again created. So instead of going through all this derivation, looking at the equation itself, we can write the overall expression, right? So I'll stop here. I think next, which is rate controlling. Based on the rate controlling, we have to write the rate. Till now, we discussed about adsorption. What will be the expression? Surface reaction, what will be the reaction? And desorption, what will be the reaction? So out of the three, what do you call, steps, only one step will be rate controlling. Based on that, if surface reaction is rate controlling, only this particular expression will take and then write the global rate. How to do that? That we will see in the next class. So in this class, we discussed how to write the rates for each one of it. Again, I repeat to you, go back to your book and then start reading the material and start deriving it. A lot of steps is being missed here. You do one by one slowly. You are writing this KD divided by KD star as a capital 1. So capital K is different, small k is different. Small k will give you either it is forward reaction or a backward reaction, whereas capital K will give you the equilibrium constant, which is 1 over the other. Understand? So with that small thing, please try to derive it. Now you see if the reaction is like this. Now see A2 plus 2x, that is two things are there. Again you can write because these two are the reactants, this is the product. So whatever reactant is there, it will come here. So A2 Cv square, because there are two vacant sites, minus Ca, again two things are there, so Ca square will come 1 by Ka, capital K. So based on whatever may be the reaction, based on that you can straight away write how to write. That is what the derivation is. Okay. Yeah, any doubt? You will have a lot of doubts. Please go through the material. If any, yeah, you get a number of doubts, I know. This material also I'll share, because this will give you good information about how to write that, right? So this also I'll put in the LMS. Some 10 pages are there, which will give you in depth of how to write the what do you call derivation. In the PPTs, the derivation is not properly given, because I am just cutting paste from the book, whereas this notes will give you the step-by-step derivation of the entire derivations. Okay. Yeah, I'll stop here. Then any doubt, let us take. Yeah, I think you can take the attendance. Vignesh, 47, I think people are. So excluding me, it is 46. Yeah, last period I'll stop here. Yeah, anything from your side, ma? If there is no thing from your side, then I can stop the sharing, and then you can leave. So I think Vignesh is taking the attendance. Vignesh? No one is there?
Taking the attendance.
You took the attendance. Fine. Good. Okay, ma. Thank you. We'll meet again tomorrow. Your class is there?
Yes, sir.
Yeah. What period I am having tomorrow?
11 to 12, sir.
Tomorrow is Friday, huh? Tomorrow is Friday. Friday we are having at 11 o'clock. Yeah, we'll meet at 11 o'clock tomorrow. Okay. Thank you for joining the last period. Yeah. Thank you. Bye.
Thank you, sir.
Thank you, sir.